Hi there, welcome to ECAS. We provide training for all things instrument and control, so please head over to our website where you can find many free downloads on a range of different topics related to instrument engineering. Also check in the comments section for links to our courses and free downloads. Now, let's get on with today's video. Hi everyone, welcome back to the channel. So in this video, we're going to discuss how you would go about fault finding an instrument loop. What you have on your screen now is a loop drawing. That would be the first thing you would do if you had a fault on an instrument loop. Unless it was something very basic, you would need to go and look at the loop drawing to get an understanding of the whole architecture of the system. So what I'm going to do is very briefly talk about the layout of the loop drawing and then discuss maybe some common faults that you would get within the loop. And then after that, I'll go on and discuss where you would start with your fault finding and what are the main things you would look for, and then ongoing from there, how to drill down deeply to find out what the fault may be that you're witnessing. So if we look at the loop drawing just now, so what you have here on the left hand side is normally your field device. So in this case, we've got a pressure transmitter. I've blacked out the tag numbers just so that it's not recognizable to the owner of this drawing. So you have your pressure transmitter out here, that will be called your field device, and normally up here somewhere you would have the area where this was located, so we just call it the field. F for field. And then next to that, it's written on it, you've got a junction box. So this is just where the wires here are connected to the wires here, because remember, this distance between here and here could be 100 meters. It could be any length of distance. So you normally need an intermediate junction box just to connect the cables. So this is also in the field. So we have this separating line here, which divides the field from this section. And this section is normally in the control room somewhere. So that's just CR for control room. And then that's in section H of the signal conditioning cabinet. Just clear some of that up. Your pressure transmitter feeds to your junction box, which then feeds into your control room. And here we've got a device, and we know what this is because at the bottom we've got MTL 787S plus. So that is a barrier. Now what a barrier does is it restricts the current and voltage out here, because this is normally in a hazardous area. Which means that it's usually on some kind of processing plant where there's possibility of getting an explosion or something. So we need a power limiting barrier in here. I've done another video on barriers, so if you want to know more about barriers, please check on the channel and check for that video on barriers. And then from the barrier in section H, it'll move to another section within the same control room onto section B. But before that, it goes into a terminal block. See here where it says TB. So that is a terminal block. So again, it's just joining cables from one part of the panel to the other, and it's TB and it's terminals 1 and 2. And from there, one signal goes down here. This is number 2, goes down here and into here, which is your power supply, 24 volt, positive and negative. So the positive from 1 goes there. So number 2 is getting the positive from here. Now this here, it says Moore DDA, and if we zoom in, we can see here on 13 and 14, which looks like a switch, an open and closed contact. So you can tell what this is because of this switch. So on the pressure transmitter, because it's a transmitter, it's giving a analog signal in. But if we look here, we can see the output is on a switch. So we know that this is transferring the analog signal to a digital signal. So it's basically a trip amplifier. So all it's doing is selecting a trip point and giving an open and closed signal out from here, from this contact here, out this way, round here, and back up to this section and into the PLC card. So they're basically using a analog pressure transmitter, which gives values in 4 to 20 milliamps, but at the end of it, all you're getting is a digital signal. So they could have really used a switch here at this point. But transmitters are better because it gives you time in the future to change it. So basically what they could do is they could remove this trip amp and put in an analog input PLC card, and that would allow them to see the actual value of the pressure in time, rather than just using it as a trip point. So basically, if the pressure gets up to a certain point, this trip amp will send a digital signal out to the PLC to signal that a trip event has happened. But that's just a brief overview of how the loop drawing actually works. But now we want to go and have a look at how we would actually fault find on this loop. So what you could have here is, because at the end of the day, it's just a digital signal, it's just a on-off signal. So what you could have here is you could either have a fault condition, and this would be shown on the screen on the HMI somewhere. So you could have a fault condition, or you could have an alarm when you don't expect to have alarm. So you could be reading that it's at a trip point, but you expect the pressure to be well below the trip point, or there's a pressure gauge there showing that the pressure is below the trip point, but your system here is showing that it's in trip. So you would have to investigate that. So this would be the first, most logical place to check, is to look at this part of the loop, all the way from here down to here. And within this part of the loop, the most logical place to step from that point onwards would be either the barrier or the pressure transmitter. The reason for that is because this is just a connection point and this is just a connection point. So the likelihood of a connection point being wrong is less likely than something with an active job. So for example, the pressure transmitter has electronics in it, obviously to transfer the pressure to an electrical signal, and the purpose of the barrier is to reduce the voltage. So it has components inside it, fuses, Zener diodes, and all these things that could fail. So the best place to start would be the most likely place of having a problem. So we've identified that the barrier is one, and we've identified that the pressure transmitter is the other. Now, of these two, the pressure transmitter has a pressure supply to it, so it has a process impulse, and it has an electronic output to it. So there's a lot going on with this device. Even if there's something blocked or because it's out on the plant, it's in the field, and it's not in the control room, it means that other people are in the vicinity. Somebody could hit it with accidentally, they could knock it, they could walk past it and hit it with a scaffold pole or something. All these things could happen. So the first place that you really want to look in the event of a fault code is you want to check the transmitter itself. So what would you do? Well, you would go to the transmitter. The first obvious thing you would do would be to check the connection points here on the positive and negative. So you would take the lid off, and you would check that the wires were fully connected on the positive and negative in case something had become loose or something like that. That would be the first thing you would check. If that looks good, then the second thing you would do would be to take a multimeter or a milliamp source, and you would disconnect one leg of these. If you're using your multimeter, so normally you would disconnect the negative side because it doesn't have any power on it. So if you touched it to earth, you would have less chance of blowing up the barrier than you would with the positive. So you would disconnect the negative side, put your multimeter in series. Now I'll show you a picture of what in series looks like at the moment on your screen now. So you would connect your multimeter up in series, and because the pressure transmitter gives an output of 4 to 20 milliamps, you would set your meter to milliamps, and you would read the milliamps that the pressure transmitter is outputting. Obviously, you need to put it in series because you need the power supply from here and here still flowing through the pressure transmitter to get the reading that's outputting. So if the reading from the pressure transmitter looks good, let's say that the gauge is showing a reading of, for example, 10 bar. And let's say the range of the pressure transmitter is 0 to 20 bar. Then you would be looking for a milliamps of around about 12 milliamps. Now, if you want to know more about how to calibrate a pressure transmitter, again, I've got a video on this. So go back to the channel, check out the calibrating a pressure transmitter and how pressure transmitters work, and you'll get a broader understanding of how the pressure ranges relates to the milliamp output. But this video is more just about fault finding from a loop drawing. So if you go to the pressure transmitter and you do indeed have 12 milliamps, and that matches the gauge that's showing 10 bar, and the range of the transmitter is 0 to 20 bar, then you know that the transmitter is working correctly. We know that that's working okay. So from there, the next obvious point would be the barrier. So to check the barrier, what we would then do is we would go to the outgoing side of the barrier, because we know what we're sending from the pressure transmitter to here is okay. So we're going to assume initially that what we're getting here on 3 and 4 is going to be okay, because all we've got here again is the connection points on here and the connection points on here. So where we want to check next is here. So how we do that is very similar. We disconnect points 1 and 2, and we connect in the multimeter or a milliamp source, and we measure the milliamps that's coming here. If the milliamps that's coming here is 12 milliamps, we know that everything's good. If the milliamps here is reading 0, but here we have 12, we know the barrier is at fault. And it's very common that these barriers go, especially the older types. The fuse inside them can blow, in which case you need to have a look deeper into the loop and try to figure out why the loop's blowing, why the fuse is blowing, or you can replace the barrier and see if that fixes the loop. In the majority of cases, it will. If it's still reading 12 milliamps here, but you have a fault code here on the HMI still, then we have to look at this device, which is the trip amp. We have to check the connections, and we have to function check the functionality of the trip amp. So the purpose of the trip amp is at a set milliamps. So let's say at 15 milliamps, this trip amp closes that switch. So at 15 milliamps, it closes the switch, puts the digital input out to the PLC, which is here, and digital input to the PLC, which is here, and that now comes up on your HMI as an alarm, as a high pressure alarm. So we need to inject the milliamps, again using a milliamp source, into points 1 and 4 and check the status of this contact. If this contact is open and closing, as it should, at the set point of 15 milliamps, then we can say that this is okay. If there's still a fault, then you need to go back and check all the connections that are beyond this point, because we've already checked this point up to here that we're getting the milliamps. So we'd have to check these connections, and we'd have to check these connections to make sure there wasn't any loose connections here in the panel. The chances are, after doing all these checks, you've already found the problem. And the highest chance is the problem is going to be, number 1, it's going to be the pressure transmitter, or number 2, it's going to be the barrier. Very, very rare cases, the problem could also be with the PLC card. Now this card is we know what it is, because you get 4 different types of PLC card. You get an analog input, which means that this analog 420 milliamp signal is going directly into the card. You get an analog output, which means that the card outputs the analog signal to, for example, a valve controller to tell the valve controller what position to go in. You have a digital input, which is what we have here, because a digital input is an on or off signal, and this on the trip amp is our on or off signal. So this card is a digital input card. And the other type is a digital output. So that's when the card will output an on or an off signal, to, for example, to a solenoid valve to operate a valve open or closed. So that's your 4 different types of card: analog input, analog output, digital input, and digital output. You also get specific types of cards for RTDs and temperatures and this kind of thing. But the 4 most common are these. So that is the basics of how to fault find an instrument loop. This would be an analog. Well, this is actually a mixture of an analog and a digital loop. It's got both kinds in it, because you've got the analog input up to the trip amp, and then you've got the digital output from the trip amp. So that's a basic overview of how to fault find an instrument loop using the loop drawing and going around it in a logical way, step by step, prioritizing the most likely faults first. Please remember to subscribe to the channel to get more content like this, and please check our website. It's linked in the description below. We have a few modules now available for purchase, and we have a lot of free downloads and information available on the website. So please go there and check. And also please check back the videos that we have on the channel, because a lot of the information that I'm going through on the video today is backed up by previous things on the channel. For example, what barriers do, what pressure transmitters do, how to use them, PLCs, all these kind of things match into each other. So please go there and watch the rest of that content if there's anything I've said here that you don't understand. And also, please, if you have any specific issues with your instrumentation and control systems, send us an email over on the website, and we'll have a look at the problem and see if we can assist with you in any way. Thanks for watching, and we'll see you next time.